Hey guys, welcome to the Hacked Existence demo of Reaver. This is an application that we use to expose the WPA2 pre-shared key by attacking WPS that comes installed on a lot of the newer routers. So first we're going to look at the results here. You can see that this is actually cracked the WPS pin, which is found on the bottom of the router here. Right there you can see security pin. That matches up to what Reaver has actually found, and it's used that to actually expose the WPA pre-shared key. And there's the SSID that we attacked. So this attack actually took me about a day and a half to pull off because the Netgear router that I'm using, I don't know if is some kind of protection that's built in to slow down the attack, or if it's just really crappy hardware and it was just over flooding. But with the default 1 second per key, I had to slow it way down to about 10 seconds per key, otherwise it would freeze up and this router would just stop responding. So here on the screen is the actual WPS key for my router. You can see it's 8 digits long. So if this was implemented just as a standard random 8 digits, that would give us 100 million unique keys, and if we were to brute force that at 1 key a second, you're looking at about 4 years to crack it, which makes it really not something you want to do, and secure enough to where anyone can implement it. Nobody's going to spend 4 years trying to crack your WPA2 key. What we found is that the last digit is actually a checksum, which means it's mathematically computed against the 7 preceding digits. So we don't actually have to guess it. We always know if we guess 7 digits, we can compute what the 8th one has to be. That brings our namespace down to about 10 million unique keys. And if we were to brute force that, we're looking somewhere around 4 months, which makes this attack viable, but I still don't want to leave my laptop somewhere for 4 months trying to crack your key. So there's some very edge cases that would implement this, but for the most part it's still rather useless. So for now we can just completely ignore the checksum because we can compute that mathematically, so there's only 7 digits we have to crack. The actual vulnerability for this whole attack comes in the way that the router checks these numbers. So what it actually does is checks the first 4 and the second 4, but since we've already computed the last digit, we only have to look at the second 3. So what this boils down to is 10,000 unique keys for the first 4 digits, which take about 3 hours. And then you only have to crack 1,000 unique keys for the 3 remaining digits, which takes about 17 minutes. So overall, you're looking at about 3 hours of crack time. And this is just because the horrible implementation that was done that checks the actual key in 2 halves instead of as a whole 7-digit key with a 1-digit checksum. So what does this mean? If it was implemented with 8 digits, we'd be looking at 4 years. It'd be really solid. In reality, it's implemented with 7 digits and some error checking, so that's a good thing. Still about 4 months. But when they actually implemented it, they split the key in half, which brings the crack time down to 4 hours. So you're looking at being able to crack anyone's WPA2 key in under 4 hours. WPS is something that doesn't really ship on commercial routers. It's meant for the residential wireless routers. So it's not something you're going to find at companies or anything like that. But if your house router has WPS enabled, it's very, very vulnerable to this type of attack. So you want to make sure that you disable WPS on your home router. Alright, so now let's look at how to actually implement the attack. This is VNC into my netbook that runs Backtrack 5, so I'm not actually doing this on my MacBook, but all the same, it's the same thing. So what we're going to do to actually implement the attack is use a bunch of programs out of the Aircrack NG package. You should check that out, really nice suite of tools. We're going to start with Airmon NG. We're going to tell it to start on interface WLAN 0. That's my wireless card interface. And you can see right here it enabled monitor mode on a new virtual interface called Mon0. So we're going to use arrow dump ng out of the same suite and feed it Mon0 as the interface. To get the BSS ID, I'm just going to cut it off real quick. We're going to get the BSS ID of Netgear, which is right here. That's the router that we want to attack. So we're going to edit and copy that BSS ID. And now Reaver has installed in user local bin Reaver. So if we run it without any options, it'll give you all the optional arguments and flags you can pass to it. So we're going to say /user local bin Reaver, and we're going to say we're going to give it Mon0 for the interface to use. We're going to give it -b and the BSS ID of the router that we want to attack. And we're going to set a couple other flags specifically for this router. So we're going to do a -d of 10, we're going to do -t of 10, and a -x of 120. And you can check out what all those flags do up here. They just put delays in between the keys because the standard 1 key per second didn't work against this router. So now I'm just going to run that. One of the cool things is if the session is interrupted or if you kill it, it'll save its state so you can resume it. But I'm going to say no for now. We're just going to start a whole brand new blank session. So it takes it a minute or two to spool up, but you can see it's already associated with the router. Oh, so one of the other things I'm going to do is add the -VV flag for very verbose, which will output all of the information that we want to see. So you can see, like right here, it says switching to Mon0 to channel 4, where it doesn't say that if you don't use verbose output. So there it goes. Now it's trying the first pin, and the little WPS lights are lighting up on my router. So it'll do this for a long time until it finally, there we go, now it got some reception from the router. And eventually it's just going to run through every pin until it cracks the actual WPS pin, at which point it'll use the pin to expose the WPA2 key.